Hello, welcome to Code Design. Today, we will be designing a system um, um, which is a connection pool and thread safe. So, what is a connection pool? A connection pool basically pools of database connection or cache of database connection that is managed by a database client or a middleware, and it reduces the overhead of opening and closing connections. So how by caching them, by creating them initially, when we start the application, it creates a pool of connections and it stores in a cache, and then it gives when you need a connection. So which improves performance, scalability in database applications. So in this design, we'll be following this connection pool interface. This interface has get connection which throws SQL exception in case there is no connection available, and interpreted exception. We have get connection with a timeout. So what happens when there is no connection to provide, or all the connection in the pool is in use? Then basically we cannot hold the thread forever or hold the client forever for a connection. So that is why we have the function long timeout. So you provide a timeout when you call this get connection. If it takes more time than the specified time provided, then it returns a null connection. And there is a function release connection, which releases a connection when you are done with your connection. You call this method release connection, but you don't call connection.close because you are using a connection pool. If you call connection.close, there should be a problem. The connection will be closed and will not be available for next use. So and these two methods, get connections in pool, are basically the stats of connection pool, like get the number of connections currently in the pool, which is get connections in pool, and used connections is the get the number of used connections. So how many connections in the pool and how many connections is in use. So here is a constraint for this one. Instance of the connection pool implementation should accept an integer, which is the maximum pool size. So what is our pool size, right? And should not create more than maximum pool size connection to the database. So there are two implementation. I have two implementation for this connection pool. One is a linked list based, and another is um, based on a blocking queue. So the one linked list based does not have thread safety, built-in thread safety. So, also the wait, right, when we need to wait for a connection, um, we need to handle it manually with a wait and notify methods. But for the blocking queue, we don't have to deal with all those things because blocking queue has all those things mechanism in place for thread safety, and blocking queue would be in Java util concurrency packages. So let's look at our list implementation. Here are some details like the database connection URL, username, database password, and pool size, and the driver name. So which database you will be using, you need to provide the driver name, driver class name for that database. And this is our connection pool, which is a queue of connection, and we create here on the constructor new linked list during initialization. And this is the code to load the driver class using class.forName. Provided the class name, driver class name, it loads the class and then it creates a new instance of the class, which is our driver class type of driver. and then it initializes the pool. It called initialize pool. So what we have in initialize pool, we are creating the number of connections that is provided while creating this object of this class. And here what we can see driver manager dot get connection. We are providing URL, username, password, username, whatever username password is provided, and this will give us a connection. And we are adding this connection to the connection pool. If we provide the pool size 10, so 10 connections will be created and added in the pool. So get connection. So get connection without any timeout. We are passing a default timeout of 100 millisecond because at least some time requires to get a connection. Even if it is 10 millisecond, it will take some time. If we provide 0, there is a high chance that you will get the exception that connection not available, SQL exception. And so this is our get connection with a timeout. So this get connection with our parameter, just call this get connection and provide a default timeout 100, or we can call directly this get connection with a defined timeout from the client that will be using this connection pool. So let's see how this method works. So if you see what we are doing here, we are taking the current time in millisecond and adding the timeout. Say if you provide 100 millisecond as timeout, from the current millisecond, whatever timestamp we have, it will be adding that millisecond. So this is our timestamp. And when connection pool dot is empty, when our pool is empty, what we have to do, we have to wait for a new connection in the pool when a connection is released and is available in the pool. So we are checking here if connection dot is empty. If it is empty, then what we need, if it is not empty, we can just go and get the connection pool dot get, and this method is synchronized because this connection is a member variable and it will be used throughout the whole class. So we need to synchronize it, make it thread safe. So here, what we see, say initially the pool is empty and it came here, and wait time. So what is the wait time? Wait time is our timestamp. Whatever is current timestamp and plus 100 millisecond, whatever we passed, and this is current timestamp. So when at this execution time. So if it is this wait time is less or equals 0, less or equals 0 means what? It means that this time is bigger. If this time is bigger, that means it took more than 100 milliseconds to come here. So it will return it will throw a SQL exception saying connection not available. Otherwise, it will call java.lang.object wait function with the specified time to make this thread waiting. And it will wait for this time, and again it will come to this loop and check if the connection is empty. If it is not empty, it will come here and get the connection. If it is still empty, it will go here and again check this condition if this condition is satisfied. So this is how this loop will be maintained, and if our wait time is negative, then it will throw the exception that no connection available. And release connection. What is release connection? We check if connection is not null, and if connection is not null, we do connection pool dot add connection. We add the connection back to the pool and notify all the waiting threads. So if you see here, there could be 5 thread, 10 thread, or more thread waiting for a connection. And once we release the connection, we will call notify all. So all the threads will try to get the connection, but only one. If there is only one connection released, only one thread will be able to get the connection, and the other threads will be in waiting state. So get connection, right? Get connections in pool. How many connections we have in the pool, and if we get use connections, the total pool size. If our total pool size is 20, and if we have 10 connections in pool, then actually we can see 10 minus 10 equals 10 connections will be used. So good to have this stat for this connection pool. So let's go to the another implementation, blocking queue. Why blocking queue? There is some advantage of using blocking queue. So let's go to the blocking queue, right? So blocking queue has those functions that we can use it. Justification for using a blocking queue, right? It has this poll function where you provide a long timeout and time unit in. You can pass the time unit, millisecond, second, whatever you want. So it will return a function. It will return a connection within the specified time. Otherwise, it will return null. So that is built-in mechanism, so we don't have to handle our wait and notify functions. And blocking queue methods make the code simpler and more readable, reducing the risks of errors associated with the manual synchronization and wait notify. So we don't have to manually handle wait notify. And efficiency is optimized for handling concurrent access and waiting, ensure better performance. So let's get back to our code, and we'll see the implementation for blocking queue. So the similar code will be here, and initializing, we are calling these and initializing the connections. But if you see this get connection is much cleaner and easy to implement. So it calls ConnectionPool.poll with a timeout, and it passes the time unit as millisecond. So it returns the connection if the connection is available, or returns nulls if within the time. If we pass 100 milliseconds, so if it is able to get a connection within 100 milliseconds, it returns the connection or it returns null. So if it returns null, you can throw a SQL exception saying connection not available. So the get function becomes very easier with blocking queue. And if it comes to interview, I would prefer using blocking queue, because it will be easier to implement, unless the interviewer asks you to not use any kind of this blocking queue where there is built-in mechanism. And release connection. So release connection is same. It is putting on the queue if connection is not null, and everything is same. Just so the blocking queue implementation looks much simpler. So let's look at our test class to test these two classes two-way. So we have here URL, which is our URL to the database. We have driver manager class. We are getting username password from environment, and we are creating a connection pool object and executing the connection. We are calling this execute query. So we are actually using virtual threads. So what is a virtual thread? Let's go and see. So virtual thread basically is an instance, is also instance of Java Blend thread, but it has some advantage over the platform thread. So what is our platform thread? Is the regular thread that we use. Why it is called a platform thread? It uses the OS thread. So virtual thread also uses the OS thread, but it uses the OS thread, but if there is a blocking IO operation, Then it suspends the thread and give the OS thread back for another thread to use. And then when the blocking I operation is done, it again acquire a OS thread. So this is how the virtual thread works. And why I'm using virtual thread here? Cause I'll be creating 100 connections in connection pool and testing with 1000 threads. That means firing 1000 queries. So if I use a normal thread, it will take more resources. Virtual thread will be lightweight and also a new thing to learn if you already not familiar with virtual thread. So these execute queries, what we are doing here, we are using Executor to create a new virtual thread per task executor. That means for each task, one thread will be used. And this is a stream. We are providing range from 0 to 1000. So it is taking 1000, it will be creating 1000 threads. And it will call the submit function with the runnable, whatever we provide for the thread to run. So 1000 threads will be created, virtual threads, and each of the thread will be calling this runnable. So let's see what we have in the runnable method. So here we are calling ConnectionPool.getConnection. And what is our connection pool here? This connection pool is using a linked list, is a list based. And if you look at here, if you see, you can see that we are using this, since we are using ConnectionPool interface, so it's much easier. Just this one liner change will switch from two different implementation of the connection pool. So here we are calling the get connection method with a specified time, which is 100 millisecond. Let's say we can provide it to 500 millisecond. So we get the connection. We are creating a SQL statement. We are running a query. I have a database sales manager. So it is calling sales manager.product. Select all from product. And we are getting the product ID. Column index one is basically product ID. So we are printing first product ID. And then this is some stats for us to see what's happening and this to see the stats. So there is the thread ID, so it will show us which thread it is inside this function or it is executing, and it will give us how many connections in the pool and how many connections is in used are in used. So this is our query, and each of the threads will be filing this query. So simple. This is our test class. So let's run this to see what happens. So you can see that it ran and it is providing the output. It provided the output. Oh, sorry. It was a previous run, and the new run is already running. Is it running? Let's see. It is running, building. Okay, taking some time to create those 100 connections in the pool. Okay, it ran. So what we can see here, um, there it returned the product ID. So each thread actually calling the firing the same query. So we are getting the first product, which is product one. And if you see thread 56 and use connections in pool 69 31, and if we go here, we can see thread 137 and connection in pool 0 and use connection 100. So again, I can see that there are some connections in the pool and use connection is getting reduced. Use connection is getting reduced, and we examine all the way end. So we can see finally at the end, there was only one connection used because most of the work is done. So the same output will be getting. Let's see what we get when we run the. Sorry, I have to change the thing. So on our test class, on our connection test, we actually have to comment this out and run this one, the blocking queue implementation. It's running, taking some time because it will create 1000 virtual threads and 100 connections in the pool. Okay, it's building. It's starting. So build finish, and let's see what we get in the output. It is taking some time. Okay, it is providing output, and what we can see here, you can see lots of connection not available. So there was it's interesting and looks like the implementation with linked list, where we handle the thread safety by ourselves using wait notify is more efficient, because we didn't see that there was connection timeout, but we can see that um, there are timeouts, so connection not available. So there was a situation when it was not able to return a connection within 100 millisecond, or there is actually, it's not actually return a connection with, yeah, the reason, right, reason there is no connection in the pool, because we are actually not only getting the connection, we are firing this query, we are reading the result set at least one record and printing this. So it's taking some time. So it ran, it worked, but it got connection not available for so many connections. But if we change the parameters, maybe blocking queue will be more efficient when we tweak the number of connections and number of threads. So I think these will be helpful. So let me know if you like this. Thank you.